In this project called the Riven Project, you're going to learn how to use the numbers from the video game Riven to create other numbers. Basically, you're learning about their number system. They have 5 unique symbols. This is the symbol for 0. This is the symbol for 1. Symbol for 2. Symbol for 3. And the symbol for 4. Notice all the symbols have this shape. So that shape remains constant. It's the stuff that's inside that will keep changing. Just keep that in mind. Oh, I forgot to write the 4. So with these 5 symbols, you can actually create any number imaginable, which is sort of really cool because we use 10 symbols, which we call 1 through 9, to create any number that we need to. Okay, so that's comma number 1, the symbols. Comma number 2, in order to create new symbols, what you do is it's a combination of rotating and putting them on top of each other. If you take any of the numbers between 1 and 4, and if you were to rotate them counterclockwise, in other words to the left, then you are multiplying its value by 5. So for example, if I took the 2, and again I'm only concerning myself with that curvy shape there, this box stays the same. If I took the 2 and rotated it counterclockwise 9 degrees, it becomes like this. And then what happens is that rotation multiplies by 5, so this is the symbol for 10. And I can do that for 3 to make 15, can do that for 4 to make 20. There's no symbol for 5. You have to think about that to make a 5. But you would not rotate 5 to make 25. These symbols individually, when you make one box like this, will only create 0 to 24. Bum bum bum. You have to do something else to make 25. Okay. When you put items on top of each other, you make larger numbers. So now that we have the symbol for 10, if I wanted to make 12, again, start with the empty box, I would put 10 and 2 together. So that's the symbol for 12. You might ask, why can't I put 8 on top of 4, whatever 8 will look like? Well, you have to go to the largest multiple of 5. So to make 5 through 9, you have to use 5. To make 10 through 14, you have to use 10. To make 15 through 19, you have to use 15, and to make 20 through 24, you have to use 4. The 0 is just there as a placeholder, sort of like how we use 0. So if I wanted 403, you would put 403. That brings us to the next part. Let's suppose we had the number 403. Well, this means 4 hundreds, 0 tens, and 3 ones. We use what is called a positional system. And if we rearrange these numbers with the same digits, notice this is not the same number. Same deal with our Riven numbers over here. If you rearrange them, you're not creating the same number. But going back to this 403, what this means is the 3 is in the 10 to the 0 place, which we call the ones place. The 0 is in the 10 to the first place, which we call the tens place. And the 4 is in the 10 to the second place, which we call the hundreds place. So again, 400 is really 4 times 10 squared. 0 in the tens place is really 0 times 10 to the first. And 3 is really 3 times 10 to the 0. Riven, these numbers, really they're called the Dunning numbers or Denny numbers. they have a base 25 system. So if I put these symbols next to each other, like if I put the symbol for 3 next to the symbol for 4, this is not 34. It's not a one-to-one transference like you would have over here. This is a 4, this is a 3 as discussed, but the 4 is in the 25 to the 0 column, and the 3 is in the 25 to the first column. So just as we did right here, to compute what this number is, you would take the face value times the place value, 3 times 25 to the first, plus face value 4 times the place value, 25 to the 0. Well, 25 to the first is 25, times 3 is 75, 25 to the 0 is 1, times 4 is 4. So this is the symbol for 79. Right. Once you unlock all the numbers for the project, namely from 0 to 52, that should be more than sufficient to be able to create any other number. So basically you might have numbers that look crazy like this one because you have them rotated on top of each other, and then if you put them in other columns, you're creating larger and larger numbers. Keep in mind though, your columns are not base 10, they are base 25. So what was just demonstrated right here was how you go from a Dini number to a Hindu Arabic number, a base 10 number. And then you can go the other way. If you wanted to take the number, I don't know, see, I should have this planned, but I don't. Oh, this hurts. What if I gave you, there we go. What if, no, I don't want to tell you 79 again. I don't know, does anyone have a favorite number? I'm totally listening to what you're saying. Let's do 52. If I gave you the number 52 and I said, okay, convert that to a Dini number, well, remember to convert from base 10, you have to divide. So since we're working with base 25, you would say 25 to the 0 is 1, 25 to the first is 25, and 25 squared is 625, and that's too big. So then you would divide 52 divided by 25 is 2, remainder 2, 2 divided by 1 is 2, remainder 0. So your answer would be 2, 2. So for the 25 to the first column, you would draw the number for 2. That's this one here. And for the 25 to the 0 column, you would draw the number for 2. That's that one there. So this is the symbol for 52. All right. So all that's different. The big thing is, remember, you are not in base 10 anymore. You are in base 25. So putting symbols next to each other, you would not read this as 34. You would read it as 79. So be careful with that. Now, the huge thing with this project is you might be inclined to use what's called the internet to get some answers. Well, don't do that, because the internet isn't always right, and there are some websites out there that actually have the wrong answer, which makes me giggle. So please be careful that you do not use the internet at all. If you are ever unsure about something, remember, the adult, professional, responsible student thing to do is to ask me a question. If you do use the internet, I will ask you to please read the cheating policy in the syllabus, because it's going to be not good. This is supposed to be a very fun project, a really good example of what we're doing in this section, and I do hope you enjoy it. And this game, Riven, is absolutely fantastic for inductive reasoning. It is the perfect example of inductive reasoning. And if you've ever played, this would be considered a point-and-click adventure. Congratulations, you've played a game just based on pure inductive reasoning. I highly recommend this series. There's a series of 6 games. and Mist was the first one, Riven was the second, and they are all fantastic. All right, good luck. Let me know if you have questions. Only me. Just tell me. Thank you so much. Bye.